In this tutorial, we will learn how to create a lift chart for a logistic regression model in RapidMiner and then to interpret the contents of the chart. In previous tutorials, you have been introduced to performance metrics like accuracy, precision, sensitivity, and so forth. A lift chart also informs you about the performance of a binary classification logistic regression model, but from a somewhat different perspective. So let's first spend a couple of minutes on what a lift chart tells you. If you focus on the picture on the left hand side, so this data set that you see above is the one that we have been using for doing our logistic regression modeling with RapidMiner, the tutorial. So it's the coronary heart disease database data set. So you have a bunch of predictors on the left hand side, some of which are quantitative, some are qualitative, and you're trying to predict whether or not the likelihood of a person being diagnosed with CHD within the next 10 years. So if you focus on the picture on the left hand side, a lift chart essentially tells you how much better your model is doing compared to random selection. So just imagine that in this data set, suppose that there were 2,000 observations, 2,000 cases in this data set. So here we are at 2,000 in the diagram. And let's say out of those 2,000, we had a total of about 200 individuals who were diagnosed with CHD. So 10% of the cases were CHD. So if we select, if we identify, or if we do our prediction randomly, then the y-axis is the prediction, the number of individuals identified with CHD, and the x-axis is the number of cases that are being analyzed. You would get the straight line slope that's upward sloping over here. So if you examine 1,000 cases, then you would be able, if you did the selection randomly, you would have identified 100 of the CHD cases. Then finally, when you look at all the cases that were 2,000, you get to 200. So the number of CHD cases that you identify as you increase the number of cases increases linearly. So it's based on the average. Okay. So that's if you do your identification randomly. That's your baseline. So how much better than that is your model doing? That's the curve on the left hand side, and that's the lift chart actually. So just from the shape of the curve, you can see that, so whatever classification method you use, in this case is logistic regression. So if you go on the x-axis, as I look at more and more cases, do you see how steeply the curve goes up? So I've been able to identify the CHD cases much sooner. So my model is much better at identifying the CHD cases, predicting the CHD cases than compared to randomly. So the steeper the curve, the better your classification is performing compared to choosing things randomly. So the picture on the right hand side is the lift chart that we got for this particular data set after training this particular data set and using a validation data set to check its performance. So as you might suspect, this black curve that you see in this picture is the lift chart for this particular model, and I'm about to show you how one would create that lift chart using RapidMiner, and then also to analyze the contents of the chart, what the chart is telling you. So let me shift over to RapidMiner here. So what I'm going to do is do this slightly backwards, in the sense that I will first show you the chart, examine its contents, and then come back and show you how that operator is set up in RapidMiner. By the way, I'm not going to go to the model on the left-hand side, the one that I just traced out with my cursor. That's the binary classification logistic regression model that you've already seen two tutorials on it. The operator that's used to create the lift chart is this one, the create lift chart, and I will come back to it once I discuss the output of this. Okay, so here for the threshold for this classification will be set at 0.1, because you may recall from the previous tutorial that we had to lower the threshold to get our accuracy performance to the level that we wanted to. I think we had set it to 80% in terms of accuracy of predicting the CHD cases, and we had to lower the threshold to about 0.1 to do that. So that's why I'm changing the threshold to 0.1. So now I'm going to run this process, and there's your lift chart. Okay, so how was this lift chart obtained? What is the interpretation of the contents of this lift chart? So you can see that there are certain buckets over here. So those roughly 2,000 cases that we had were divided off into buckets of 50. That's why you see 25 over 50, 15 over 50, 17 over 50. So we created buckets of 50, and the way this lift chart was obtained, so let me just explain to you how this lift chart was obtained so you can interpret all these numbers that you see next to the bars and also this cumulative black curve. That's the lift chart actually. So let me go to the output from this logistic regression model. So you may remember the way the logistic regression modeling works is it uses the predictors and comes up with a probability calculation, a probability value that that particular observation belongs to the CHT category. So that's this confidence value that you're seeing. Okay? And if that probability is above a certain threshold, we had set our threshold to 0.1. So if the probability is greater than 0.1, then the model would say, I predict that this individual will be CHT. If the computed probability is less than 0.1, less than the threshold, we would say it's not CHT. Okay. So the way the lift chart is obtained, at least conceptually to think about the lift chart, is let's sort all the observations by the probability of being in CHD. So this column that you're seeing over here that I've identified with my cursor is the probability of a particular person observation being in the CHT category. And you can see this first one is 0.94. Since this is more than 0.1, the prediction from the model was that this is a CHT. And it actually matches what the person ended up being in the data set. So the prediction and the actual value matched. Okay. Now, so if you keep going, so what we have done here is we have sorted the cases. You can see these cases, and now these row numbers are the case numbers. So we have sorted the cases by the probability of being CHT. This is the probabilities obtained by the logistic regression model. And you can see all these predicted values are ones because all these probabilities are higher than 0.1. Our threshold was 0.1. And if you scroll down, let's see, we'll go all the way to 0.1 here somewhere. Okay, so you can see, let's see, go up to 0.1. All right, so here we are, we're at 0.1. So as soon as we drop below 0.1, 0.099, the model is saying, no, this person doesn't belong to CHT, so CHT category, that's the prediction. So above the threshold, we categorize it as CHT, the model does. Below the threshold, it's not, okay? Now, the prediction is not always correct. So you can see, for example, when you go to case 81, the predicted probability was 0.634. Since it was more than 0.1, the model predicted that this individual will be diagnosed with CHT, but in reality it turned out to be 0. So the model does make mistakes. So what the lift chart does is it, after sorting the observations by the predicted probability, it breaks it up into buckets, and you can set the bucket size. In this case, the bucket size set to 50. So imagine that we take the first 50 values here. Okay, so we go down, I don't know where that would be, but let's say we go to the first 50 values. So we have 50 observations. Out of those 50 observations, how many did the model correctly identify? So if I were to pick the first 10, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of the first 10 cases, you can see that the model picked 8 of them correctly because it misdiagnosed these two. So 8 out of 10. Okay. Similarly, if you think of a bucket of 50, the first 50, how many did the model correctly identify? So this 25 out of 50, what this bar is telling you is that after sorting the cases by the probability of being in CHT category, the model correctly identified 25 out of them. Okay, so it's already done a good job. Half of them it identified correctly. So out of the next 50, it identified 15 correctly. Out of the next 50, it identified 17 correctly. Okay, so actually what I did was I took those numbers that were there in the RapidMiner output and I put them in an Excel spreadsheet here, and I've done the calculations for you. So here's the 25. I've actually calculated how many of those cases were correctly identified. So I just added up the cases that were correctly identified, so 25 out of the 50, and that's where that 25 came from. So the black curve that you are seeing is simply the cumulative. The 25 plus 50 plus 17 would give you this value, plus 11 would give you this value, plus 14 would give you this value, and so forth. And ultimately, when you get to the last bucket, the model has identified all 100% of the CHD cases. Now, a preferable lift curve would have been one that is steeper, so it goes up like this and flattens out very quickly. Ideally, it should go up here and then be flat after that, but obviously one doesn't get that in practice. But the steeper the lift curve, the better off you are. Now, if this curve had happened to be very flat, something like this, then we would say the model is not doing much better than random. Okay, so I hope this explains to you the interpretation of the lift chart, how to interpret its contents. You can set the bucket size and so forth. So let me get back to design and show you the parameters that you have to set for the lift chart. So the lift chart operator, you can just search for the create lift chart operator here in the operator panel. So so when you create the lift chart, one of the things you have to specify is there are two. This is binary classification. So you have to tell the RapidMiner for which category you are creating the lift chart. So here we are creating the lift chart for the category CHD, that is the likelihood that this individual belongs to the CHD category, is predicted to be in the CHD category. And that was target class 1. The other class was 0. And then there are a number of different ways to set up the bins. Okay, so you can specify how many bins, or you can specify the size of the bins. Here I've set it to absolute, and I said that each bin should be of size 50. So I think, I don't know, remember how many cases there were, maybe 1,000 cases, 1,500 cases. So you can see how many bins there would be. And once you've done that, RapidMiner would create the chart for you. So creating the chart is fairly simple. And in terms of the inputs that have to be given to the create lift chart, obviously you have to give the model. So the rest of this picture, the rest of the process over here is your standard logistic regression model that you saw in the previous two tutorials. So all that we've done is taken the output and fed it into the create lift chart operator. So it needs to have the predicted values that come out of applying the threshold and the model itself. Okay, so once you provide these two inputs to the lift chart, the RapidMiner will create the chart for you, and you can analyze the chart. So once again, going back to the results, I hope you were able to understand what a lift chart tells you. It informs you about the performance of the model and how well it is doing in its classification compared to doing the classification randomly. Okay, so I hope this tutorial will be helpful for you in understanding what a lift chart is, and thank you for listening.